Hello. All right. Hi. As people are making their way to their seats, we'll just talk about the basics here. My name's Brian Krantz. You can just call me Brian. And I will be lecturing here for Chem 1A, the Chem 1A lab. And I have posted lots of documents on BSpace. Please familiarize yourself with BSpace. So my email is bakrantz@berkeley.edu. And there are other people that you'll want to get to know. For example, our head GSI, Beatrice Brando. And if you have a problem with the sort of mechanics of the course, there's a Google email account set up for her. Really, it's best email me for really, I think, higher level questions involving course content and things of that sort. And then there's some lower level things involving, getting your clicker to work. Please email the clicker. There's a clicker BSpace email set up for that, where people can help you with that. And if you have a sapling issue, please email sapling support technician, which is Anthony. And there's an email for that. I can't really do any manipulations of the sapling system because it's like in Texas, and so that's where Tony lives, and he'll help you there. And if you have an enrollment problem, for example, I have a little bit of an offset here. If you have an enrollment problem, talk to Dr. Lamoureux. Dr. Lamoureux. And he will deal with your enrollment problems. And enrollment issues include, I'm on the wait list, and I'm number 3 or 4, or whatever. I want to switch labs, and there are things of that nature. Please email him. I cannot control anything involving the wait list. I have absolutely zero power, and he may be able to help you. But if you're far down the wait list at this point, I wouldn't have too much hope. If you're 1 or 2, you might have a chance. I'm sorry, but we have limited space in the labs as it is, and it's a safety issue. We can only have so many people in there at once. All right, and so those are the basics. And what I wanted to do is just introduce, why is Chem 1A lab so important, especially for non-majors of chemistry. And I think, it's a great gateway course to hopefully recruit people into what we call the STEM fields. These include fields that are intimately involved in science, technology, engineering, and mathematics. And we really, when we hear about the economy, being in the doldrums, and there's a lot of unemployment. These types of jobs actually have very, very low unemployment. They're very high-paying jobs. But really, you need to excel in these kinds of careers. You need to develop skills, involving the scientific method and deductive reasoning, and being able to hypothesize, design experiments, observe, repeat, and communicate your results, which is really what we want to do here. And the main subject matter, like we could pick, the typical sort of Gen Chem material, but we've now moved into a new direction called green chemistry. Oops, I have a little bit of an offset problem today. This is really, I need to fix this. I'm sorry. Yeah, my pen is not where it's writing, so I need to do an alignment. The resolution that they put me at here changed the offset. Okay, so hopefully now I can write. So yeah, we're interested in green chemistry, and the idea of green chemistry is to design chemical products and processes that reduce the formation of hazardous products, and this is important, while maximizing energy efficiency. And so that's the key. I mean, we want energy efficiency. We want to reduce hazards and in our chemical processes and our chemical products rather and processes. And so you can think today, of course, when we have environmental catastrophes where industrial spills. Wouldn't it be great if that material, let's say, spilled was actually easily cleaned up and the products of it were fairly biodegradable, or they could be degraded with, say, the introduction of, say, a bacterial species or something to that effect. But we could develop an industry and processes that prevent waste. The products are safer, and these are sort of the bulleted points in your lab manual. The processes were safer, and they use renewable resources. These processes use catalysts instead of stoichiometric product inputs that would lead to a lot of waste products. You're trying to avoid chemical derivatives, especially toxic ones, and really improve what we call the atom economy. The atom economy idea is that when you have feedstocks going into making a particular chemical product or process, that those atoms are all used. There's no waste atoms. And we're using safer solvents, again, emphasizing energy efficiency, because solvents are use organic molecules that come from, say, petroleum products. We'd like to minimize the waste of solvents, and then thereby increasing energy efficiency. That the products are maybe biodegradable, they minimize pollution, and the most important, I think, is that all these processes in chemistries are safe, and there's minimal chance for accidents. Accidents are minimized. And there's many different ways of thinking about this sort of thing. One thing I know, this rendering is not going to work of my screen. I can't scroll. This is really a shame. Okay. So normally I can scroll down the page. All right. So the course logistics are that we of course are going to have a lab lecture. And there's 2 lab lectures. There's an evening one on Wednesday, and then of course you're here on the Friday one. And this means, because the material's repeated, we have so many students they can't all fit in here at the same time, that you can come to either if that fits your schedule. I know that's not going to be a convenience for everyone, but I just wanted to lay that out there in case something comes up. You have a doctor's appointment or something like that. I will have my office hours in Stanley Hall, room 476, and again, these hours can be adjusted a little bit if it comes up that there's a big problem with them. But Monday 1 to 2 and Tuesday 2 to 3, and all this information is on BSpace. So we're going to have this is going to be the total points in the course. We're going to keep it a nice round figure of 300, and that's going to come from primarily from your labs, of course. We're going to have 80 points for what's called a lab exam. This is not a final exam. It is before finals week. We're not allowed to offer a exam during exam week, and so we call it the lab exam. And that's really important to make sure that each of you individually learned. And then we'll have 2 reports. These reports are summation reports, and These summation reports are going to be on biopolymers and biofuels. When you get to that part of the course, that point in time, I'll pass out a handout, and it will detail sort of a way of thinking, perhaps how to write a basic lab report. It's not going to be a real lab report. It's going to be very guided, but it's a time for you to show off your thinking and your lab reasoning skills. Okay, so did I? Oh, I'm sorry. That's my bad. Wow. Is that? Yeah, I don't know how that happened. Math skills are important for STEM fields. There are weekly labs. The weekly labs are each worth 20 points. And so if you do your math there, you'll see, well, if I had 12 weekly labs with 20, this is not working out well today. That's 240 points. But remember, we have one dropped lab. So whatever, one dropped lab. And so then you'll have a total of 220 points. So what that means, it's a logistical nightmare to deal with 800 students, and potentially during the course of the semester, there could be several hundred really good excuses for missing a lab. And we don't actually want to hear about that at all. Okay, we just say, look, that's fine. We know that that's going to happen, and you can miss that lab. And for people that actually do all 12 labs, then you just drop your lowest score. So it works out as sort of a bonus for people to do all the labs. They get to drop their lowest score, and it also helps out everyone else. Okay, so yeah, so the reports, one of the labs isn't really a wet lab. It's going to be this PowerPoint presentation. And you'll see in your manual, your lab manual, which here's your lab manual. Everyone has one of these. Be sure to get one of these at the bookstore, and a notebook, which is basically an empty book of graph paper. And in your lab manual, you'll learn about this PowerPoint presentation we'll do on the biopolymer section. And so that's part of the labs, and then so that's sort of like a project, a mini project, and then there'll be these two summation reports. So these reports will be on biopolymers and biofuels. Okay, so those are the two reports. I can scroll with my mouse. That's kind of cool. All right. And then so we have the exam, and the exam is May 2nd. Well, it'll most likely be in this room. It's 7 to 9. But. Okay, and so the labs themselves, how do they work? And the basic idea of the labs is we're going to have this pre-lab. And we're going to do this on this computer system called Sapling, which I hope everyone is working their way through to get registered and logged into. And the key thing to note is that when you do the Sapling exercise, and I hope people have started to do some of the preliminary assignments for that, you'll see that as you fill out these questions, what we want you to do is to write the answers in your lab notebook. And that way the GSI can grade them. And we're also going to make sure that you log into the system into the exercise. And the reason we're doing that is because sometimes there are computer glitches, and you can't get your question answered even though you know the obvious answer to that question. And so it's a lot better to have a hard record that you did the pre-lab. And so basically the GSIs will then look over your notebook to make sure that you did the pre-lab. If you don't do the pre-lab, if it's not finished in time, then you can't start the lab and you will get a 0. Okay? Because if you don't do the pre-lab, you're not going to be prepared to do the lab. You're going to be asking lots of questions. You're going to be confused, and the GSI would be spread way too thin if say 5%, 10% of the class were confused because they didn't do the pre-labs. So just yes. Okay, that's a good question. So if you look at the smell pre-lab. So the question is, okay, so if you look at the smell pre-lab here, you'll see that this is actually exactly the same material that's in Sapling. And you might think that that's going to happen lab after lab, but you're not going to be that lucky. So this is just to help people that really have trouble getting into Sapling, and you're actually going to put this into your lab notebook. Okay, so this is for people that have trouble, and that's what it says at the top. So this information is nearly identical to the work you'll see on Sapling. Please only work on this if you've not been able to log into Sapling. Okay, but yeah, that's a good question, and that's how we're working it. I guess in the past, we had more paper in the notebook for that, but we've tried to slim it down and have it online. Okay, so pre-lab on Sapling, you have to do it. It's compulsory, and then you will listen to your GSI and do your lab. The key thing is that you're there. You're in lab right at the start. You don't come in late. If you come in late and you miss all the safety instructions, you're not allowed to do lab either, okay? Because it's just an unsafe situation. And we can't have the GSI doing another safety demo at the beginning, as students trickle in. So be sure you're there on time. So then at the end of lab, you turn in your carbon. You might say, well, what's your carbon? Well, your carbon is the duplicate copy of everything you did in your lab notebook that day. And you just turn that in, and that's graded. By the way, this pre-lab is 5 points. This carbon is 5 points. It's pretty straightforward. And then, in the next week, you will turn in your post-lab. And the post-lab exercises are not on Sapling. They're right in your lab manual, and you'll see all those exercises. And you'll turn that in, and you'll get that graded for 10 points. So that gives you your grand total of 20 points. Okay. So question? How's the carbon graded? It's graded on a triage basis, which I say is it there, is it not? Does it have the basic components of good notebook skills, which I'll get to here. I mean, if it's really quite poor, you're probably going to get 1 point or 2 points or something. You'll get points taken off. But good notebook skills. I mean, yes? I have to defer to the GSIs. I think it's turned into the next lab, the very next lab section at the beginning. So we're not working on it during that, because you really want to save yourself that time to do your next lab. So have it ready to go on the next week. It's not turned in. I mean, that's the easiest logistic thing to do. Any other questions? Would your post lab be done? No. Yeah. I mean, they're... Okay, yeah, so sorry, the GSIs know more than I do. The GSIs will tell you all this stuff in section 2. So that's the best thing. It's just in section you'll learn about the details. But yeah, you'll tear out these sections from the lab manual and turn those in. And those will have your questions on it. If you need extra sheets of paper, feel free to put those in. You'll staple that together and turn that in. Any other questions? Question? Yes. It's much better to do it that way because we're not going to go off the score you get on Sapling. We're just going to make sure you have the right answer in your lab notebook. And sometimes it flakes out. Your browser's not working well that day. God knows. And so it's much easier than to just write it down in your notebook and then for us to grade it that way than for the GSIs to have to log into the computer system and check that everyone did it. So you'll find that this is actually a good way to do it. So as you're doing it, just write down your same answer. Okay, there's also another issue with that. Sapling doesn't allow you to print. The print function is disabled for various intellectual property issues. I don't really know the full ramifications there, so it's a lot easier for us to just do it this way. You, by all means, can use any computer technology you like to print from the screen if you like, and put those in your notebook. Go for it. But we like to just say write it out because that's the lowest level technology, easy to do. It's Sapling that's encumbered us there. Okay, for notebook skills, I mean, what we really like you to do is have good notebook skills. And we'd like you to, give a title, give a title to your experiment, put it in the table of contents page on the first page of your notebook, and then immediately state your hypothesis. It could be a hypothesis or hypotheses. It doesn't matter. You have a couple of hypotheses going in, and then what you're going to do is when you look through the lab manual, you want to list out your procedures that you're going to be following that day, and then you want to basically, basically record data and observations, and try to do this as neatly as possible, so that of course, you can read this afterwards, okay? And so it'll be important for later in the course when you write these summation reports. You can read your observations and data, and then at the end, these conclusions may not be great, but it's good to state a brief conclusion. For not a paragraph or anything like that, that's brief. But just some very brief conclusions that summarize what you observed. And did it agree or disagree with your hypothesis? What did you learn from these experiments and data? Okay, so that's the basics there. So, okay, the key thing here that I want to just brush through is safety, and I'm not going to write down too much so I can get through it pretty quickly, but it's very important. When you start lab, you are going to have to complete a checklist, a safety checklist with your GSIs, and during that, you're going to learn all about what happens in case of an accident or an emergency. For example, you're going to need to know where the eye washes are and the safety showers in case you spill chemicals into your eyes, and you shouldn't because you should be wearing goggles, but it may happen in some weird way, but hopefully I won't hear about that this semester. There's safety showers in case you have spill on your clothing or your skin, and how to fill out accident reports, where the emergency phone numbers and contacts are, and what to do in case of an earthquake or fire in the building, and how to get out safely. So that's it for accidents and emergencies, and then we have our SOPs, our safe operating procedures. And our SOPs, and the SOPs are listed in a notebook, like typically in an industrial process or any sort of chemical synthesis. You might have particular ways that you should configure equipment or that you should deal with particular hazardous compounds or reagents. We call those safe operating procedures, or just SOPs for short. And the key above all, safe operating procedure in the laboratory is to wear safety glasses. Number 2 is appropriate laboratory attire needs to be worn. And I'm going to emphasize this before lab start next week, that people wear basically the kind of clothing that I'm wearing, shirts that go all the way down their arms to their wrists, okay, no short sleeves, and long pants where there's no skin showing all the way down to the tops of your shoes, and then I have closed-toed shoes on, okay, and no flip-flops and this sort of thing. It's really dangerous in the lab. Glass can break, acid droplets can spill onto your exposed toes. So the key thing is that everyone does this to the best of their ability the first week of lab, because if too many people come in with the wrong attire, then Cal OSHA will not let us let you run your experiments, okay, and we only have so many extras of long-sleeved clothing and pants to help people out. So this means no dresses. I'm sorry for people that like to wear dresses on lab days. You can wear them afterwards. And yes, sorry. Yes, there will be safety glasses in the lab. Well, what you'll do is before you start lab, you'll want to write out some hypotheses and some list of procedures you'll do that day. If you change them, then you just say, I changed my procedures. But then you just record your data in just a linear list. The lab notebook isn't really a pretty document like a final report. It's just sort of a continuous scrolled listing of what you're doing. No, that's your personal lab notebook. It's your diary. You just need to have all the stuff there. Some people try to think, they think when they're doing their experiments, they can just remember everything they've done and they don't record it in a notebook. And so this is an important skill to have, is to basically make a good diary. Okay, so, sorry, those are the basic safe operating procedures. I think, okay, I'm sorry, I need to finish these. So we'd like you to be neat in the lab. Being messy leaves, chemical spills all over the place. Other people will touch them accidentally. It's kind of dangerous. We want you to wear gloves when you work with corrosives. Know how to use the fume hoods and use them when they're required by your GSI, when they're required and your GSI tells you about them. Be careful with glassware. Avoid, punctures and other problems. Know how to handle broken glass properly. Learn about that, how you add acid to water. You don't add water to concentrated acid. It's quite dangerous. It can heat up and splatter on you. And avoid waste and excesses. If that calculation says you need like 300 grams of something, be sure that's right. It's not 3 grams. Don't just chug along on your experiment. If you see everyone else in there kind of weighing out a small amount, you're weighing out a huge amount, because that waste will have to be taken care of. And when you're heating test tubes, be sure not to aim them towards your lab mates or yourself. And above all, follow the GSI instructions at the beginning of lab. That's why you need to be there at the very beginning. Okay, so the last thing on the safety list is how you deal with chemical waste and then general waste. And the key thing is to think about the environment here. There are many different waste receptacles. And we have waste for chemicals. Those are very specific wastes, depending on whether it's corrosive, organic. You have to really be careful. You don't want to put the wrong chemical waste into the wrong container. And then we have basically regular, at the bottom here we'll have regular trash. This means do not put your chemically contaminated gloves, eyedroppers and things in the regular trash. And then we just have, your chemical, what do we call it? What kind of waste do we call this? Lab debris, sorry. Let's call this lab debris. Your lab debris are basically things like paper towels, gloves, and droppers and things that have chemicals in them. They have to go specifically, broken glass, things like that, into specific lab debris. Obviously, those aren't liquids. So these are your chemical liquids. Spent bulk chemicals can go in lab debris. So different trash cans. Don't put coffee